In the previous video, we defined a secant line. We said that a secant line was a line that connects 2 points on a function, and that's what we were using to approximate that instantaneous rate of change. We used, if you go back to that quadratic parent function, we used the 0.24, and then we took another point. We started off with 416, and we found the rate of change between those points, and then we started moving the point closer and closer to 2, but we kept finding the rate of change of a secant line. A secant line connects 2 points of a function, and its rate of change equals the average rate of change of the function on that interval. So if you go back to that very first point that we used in the previous video, where we took 2, 4, and we took 416, and we found the rate of change between those 2 points was 6, you could say that on the interval from 2 to 4, the average rate of change of our function f of x was equal to 6. And then we started approximating by making it closer and closer. And what we were actually in the process of finding, that we'll kind of formally define later on, is this idea of a tangent line. And a tangent line is a line that shares a point with a function and has the same rate of change of the function at that instant. So what a tangent line does, and we kind of actually really could have set this up, but we'll do that later on in this class. If you go back to the previous video where we were able to say, as delta x was getting closer and closer to 0, my instantaneous rate of change of f of x was getting really close to 4. What a tangent line is it would go through the point 2, 4, and it would also have a rate of change, or in this case a slope, of 4. And so we could have written the equation of this tangent line because we knew a point and we knew its slope, but it is a point, it's a line, it shares a point with a function. In the case of the previous video, it would share the point 2, 4, and it has the same rate of change of the function at that instant, which would have been a rate of change of 4. And so just kind of stick a pin in these two definitions and associate a secant line as being the rate of change between 2 points. And that's going to be the average rate of change over that interval. And then we have this idea of a tangent line, which goes through 1 point of the function and shares the same rate of change. So stick a pin in these definitions because they'll come up time and time again in these first couple of units of calculus.